Back to lesson 7.2 where we're going to talk about some more SOHCAHTOA stuff. So let's look at example number 2. It says if cosine of A, so A is our angle, equals 2/5, we want to find the other 5 functions. So I want to find sine, tangent, which we know they're going to be fractions, cosecant, which pairs with sine, secant, which pairs with cosine, and cotangent, which pairs with tangent. I want to find all the other ones, knowing that cosine of A equals 2/5. Now, this problem, our first step is to work backwards a little bit. So step 1, I'm going to work backwards and draw a right triangle. So there we go. Here's my right triangle. And I'm going to call either one of these angles A. It doesn't matter which one is A. You'll end up with the same answers. So let's call this one A. We'll just pick one of them. Now, next step of working backwards. I know that cosine, SOHCAHTOA, is going to be adjacent over hypotenuse. SOHCAHTOA. So if I label these sides on my triangle, then I can say the adjacent side is 2 and the hypotenuse is 5. So let's do that. So remember to label them. We always do the hypotenuse first because it's across from our right angle. So there's my hypotenuse. Then we do the opposite side because it's across from the angle we're focusing on. So there's our opposite. And then finally, the one left over is my adjacent. So I can say right here that my adjacent side needs to equal 2, because that's what my cosine tells me. The numerator, the 2, should be adjacent. And then I also know that my hypotenuse should be 5, because the denominator on cosine is always the hypotenuse, so the hypotenuse is 5. Now, I still don't know what my opposite side is. However, this is a right triangle, and I know 2 of the sides, which means I can do Pythagorean's theorem to find the last side. So remember, A and B are your short sides, so opposite squared plus adjacent squared equals my hypotenuse squared. Let's plug in what we know. We don't know opposite. The adjacent is 2. The hypotenuse is 5. So the opposite squared plus 4 equals 25. So I'm going to minus 4 to both sides. So I get opposite squared equals 21. Square root the opposite to get rid of the square. So I know that my opposite side is the square root of 21. There we go. Opposite square root of 21. And now I can fill in the rest of all of these things. So let's start. Sine is SO, opposite over hypotenuse. SOHCAHTOA. So the opposite side is square root of 21. The hypotenuse side is 5. So there's our answer. And remember, to get cosecant, it's paired with sine, so we just take the sine value and flip it. So instead of square root of 21 over 5, it's going to be 5 over square root of 21. Okay, next, I know that my cosine is 2 over 5, so my secant should be it flipped 5 over 2, because secant and cosine are paired together. Okay, next, tangent, SOHCAHTOA. So that's going to be opposite over adjacent. Well, my opposite side is square root of 21, and my adjacent side is 2. So there we go. And cotangent is paired with tangent, so we just take the tangent and we flip it. So instead of square root of 21 over 2, it's going to be 2 over the square root of 21. And there we go. Okay, we have one more example that's exactly like this. So we know that tangent of B equals 3 over 7. And we want to find the other ones. And I want you to try this one on your own using the example that we just did. It's going to be the same exact steps. You're even going to have to use Pythagorean's theorem in the middle to solve for the third side. So you're going to draw your triangle, fill it out with your tangent, and then use Pythagorean's theorem to solve for the rest of the sides, and then fill in the rest of your ratios. So pause the video, try that part out on your own, using the exact steps from up here, and then come back and see how you did. Check what you got with what I got. So first off, we knew that tangent was 3 over 7. Tangent is SOHCAHTOA. So O should be 3, A should be 7. So I came over here and made O 3 and A 7. And then I used Pythagorean's theorem, a squared plus b squared equals c squared, or O squared plus a squared equals h squared. So O was 3, A was 7, and I solved this out to get h is the square root of 58, so I plugged that in. And then I used that to fill in the rest of these. So sine is O over h, so I did O over h. So cosine is a over h, 7 over square root of 58. Cosecant is paired with sine, so I just flip sine. Secant is paired with cosine, so I just flip cosine. And cotangent is paired with tangent, so I just flipped my tangent value. And there we go. That is it for SOHCAHTOA. In the next video, we're going to use SOHCAHTOA to come up with some slightly different definitions for sine and cosine and tangent.